Hello, can you see my screen? Thank you. Right, so let's look at, welcome everyone. Let's look at exam revision 2. We'll see if we can solve as many problems as possible. So let's go back to the first question here. So we're looking at using synthetic division to find all the values of k for which x minus 1 is a factor of the polynomial k squared times x cubed minus 7kx plus 10, right? So obviously, if x minus 1 is a factor of this polynomial, then when you do synthetic division, the rest should be the rest, or what you might call the remainder, should be 0, right? So let's try to do the synthetic division here. So if you divide k squared, k is a constant, right? So k squared times x cubed, right, divided by x minus 1, you get k squared, right, times, or rather, let me write it down. So you get k squared times x squared, right? And then when you multiply that in, you have now, right, you have k squared x cubed minus 7k minus 7kx plus 10, all subtracted from k squared times x cubed minus, well, it would be plus now, minus, so plus k squared x squared, right? And that will give you k squared x squared, right, minus 7kx plus 10, right? So then when you divide this remainder, well, this quotient here, so when you divide rather this polynomial that you found here, the k squared x squared minus 7x minus 7kx plus 10 by the x minus 1, then you get, right, plus k squared x, right? And then when you multiply that in, you get minus k squared x squared you get plus k squared x squared yeah, plus k squared, oh wait, sorry, kx, you get k squared x squared plus k squared x, right? And when you subtract the two, what you're left with is k squared minus 7k all multiplied by x, right, plus plus 10, right? And when you divide this by x minus 1, you get plus, right, k squared minus 7k, and when you multiply n, you get minus k squared minus 7kx, oh sorry, k squared minus 7k all multiplied by x plus k squared minus 7k, and that will give you, right? Now you will eliminate the terms in x. You will only be left with k squared minus 7k plus 10, right? And remember the criteria for x minus 1 to be a factor. So for x minus 1 to be a factor, the remainder that you have here has to be equal to 0, right? After you've done the synthetic division. So what you need to do now from there is you need to equate the remainder to 0. And when you solve for k, right, what do you get? I want you guys to give me the two values of k that you get.
5 and 2.
Right,
Minus
so
5 and 2, yeah.
Sorry?
Just 5 and 2.
5 and 2. Right, so you get 5, k is equal to 5, or k is equal to 2. Does everyone agree there? Just give me a minute. Right, so now you have the two values of k that make the remainder of the synthetic division be equal to 0, right? So now, as soon as you have that, you've immediately find the value that make x minus 1 a factor of the polynomial. So these are the two values that you should consider, right? Any questions there? All right, moving on. So we have to solve these limits without using L'Hopital's rule, right? Now, of course, we know that L'Hopital's rule is very convenient in solving these problems. So it would be very easy to use it and solve the problems, but they want us to not use it and just find other ways to solve this. So for limits like this, right? For example, the first example here, you see that you have a polynomial under the square root sign, the limit of a polynomial under the square root sign minus the minus another polynomial under the square root sign, right? So as soon as you have that, if you substitute in the value of x, because you see x is tending to negative infinity. So if you substitute in the value of x, what you will get is you'll get that it's equal to, right, infinity minus infinity, right? So you'll get something like infinity minus infinity, right? Which is an indeterminate form, right? So you have to manipulate the limit, since you can't use L'Hopital's rule, and you can't even manipulate it to use L'Hopital's rule, so you just have to manipulate it to use other rules that you can think of, right? So usually what you do in these cases, you multiply and divide by the conjugate, right? So you guys have seen that. So you multiply by the square root of x squared plus x minus 1 plus the square root of x squared minus 1, all divided by the same conjugates, right? So, just give me a minute. Right, so divided by, please mute yourselves. Anyways, I'll just leave it like that. So yes, you multiply and divide by the conjugate, right? And then when you do that, what you get in the numerator. So in the numerator, right, you will get, when the two brackets multiply, you will get in the first bracket, or rather you'll just get x squared plus x minus 1, right? Under the square root sign squared, which will just give you x squared plus x minus 1 minus, right, the second square root squared, right, which will just give you x squared minus 1, right? So that's for the numerator. But what happens in the denominator? So in the denominator, you have now the same thing. So you still have, right, sorry, just do that, and then copy that, right? So in the denominator, you still have the same thing, right? But in the numerator, you can already see that we can simplify. Yes?
Sorry.
Yes.
Aren't you supposed to negative in the numerator? Aren't you supposed to have negative x squared plus 1 instead of negative 1?
Oh, yes, sorry, that's my mistake. It would be plus 1. I meant to put a bracket there. Thank you. So yes, so that's what it amounts to. So then obviously you can simplify by eliminating the x squared, right? So you eliminate the x squared, and then you're left with the x minus 1 plus 1. So the 1 also is eliminated. So you're left with x in the numerator, right? Divided by the sum of these square roots, right? So now when you have the limits of the quotient of two polynomials as x tends to infinity, right? You remember that one of the ways you can solve that limit is by taking the highest power in the numerator and dividing it by the highest power in the denominator, right? Oh, sorry. And dividing it by the highest power in the denominator. So in the numerator, we only have a term in x. So the highest order there is just 1. So x will stay. In the denominator, under the square root sign, we have a polynomial of order 2. So we'll keep the term in order 2 and remove all the lower order terms, right? And so that's what you're left with. But now, what is the square root of x squared? So this is where you have to pay attention, right? Because it's very important. So as x tends to negative infinity, it means that x is a negative value, right? So when you take the square root of x squared, you have to write it in the absolute value form, right? Because x can be positive or negative, and in our case, x is negative, right? And if you go back to your piecewise definition, you have that when you have the absolute value of a function and they tell you that x, for example, when you have the absolute value of x and you have that x is tending to a negative value, then you can just replace the absolute value by the negative of the variable. So it would be negative x, right? Plus negative x, which is just minus x, right? And then when you have that, the limits can be further simplified to give the limits as x tends to negative infinity of x divided by negative 2x. So just give me a minute. I'll be back. Right, sorry about that. So then you can simplify the limit to be as x tends to negative infinity of x over negative 2x, right? And the x can cancel, and then you'll have the limits as x tends to negative infinity of negative 1 over 2, right? Negative 1 over 2, which will just give you negative 1 over 2. So really what's important when you're solving this particular limit is to look at whether x is tending to a positive or a negative value, because that makes a big difference, right? Yeah. Okay, so moving on. Okay, so moving on, you have